Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to IYS online teaching. This is me, the host of today's class 9-10 maths meeting. Right. Today we will work on chapter number 2. This is the continuation of system of real number, and today will be the last exercise of the chapter. This is 2.8, and pages which are involved in this content, they are page number 46 to page number 48. And the topics of the day which we will discuss, that they are define surds, means what are surds, how will we elaborate the definition of the surds, and then how to simplify the surds, which is based on exercise 2.8. Okay, so let's start the topic. They are surds. What are surds? How will we define a surds? Surds are numbers left in square root form or cube root form, or like that fourth root, fifth root, whatever the value of your index. They are therefore irrational numbers. The reason we leave as surd is because in decimal form they would go on forever. Means it is simple to understand that what are surds. Surds are the radical expressions which cannot be extracted out from their radical sign. That is, they are the irrational numbers. When we solve that radical sign while using either by your calculator, you will find that the value will be after decimal point, it will be goes on, and again we will have the different numbers. So when you will solve that surd, you will get irrational number, and that surd may have the value of the index as 3, 4, 5. So they are the numbers, they are the expressions which will be inside the root after solving the root also, right? They can be not simplified from the radical sign. For example, here we have square root of 11, and it is mentioned that it is a surd. Why this is a surd? When you will solve under root 11 by using your calculator, you will get 3.3166 dot. What does this mean? It means that the division is going on. It is non-terminating as well as non-recurring. So you may check this by using your own calculator, so you will be easily understand that why root 11 is a surd. It means, another meaning is that while making the factors of 11, we are unable to get the two identical factors of 11. That's why it is a surd. Whereas example B is saying that 4 is not a surd. 4 is not a surd because 4 is a integer. All the integers are not a surd. Surds are only those expressions which are enclosed in the radical sign, and even after simplification they cannot be extracted out from that radical sign. For example, number C, root 9. They are saying it's not a surd. Why it is not a surd? Although it is having the radical sign, reason is that under root 9 means square root of 9. We are able to make the two identical factors of 9. They are 3 multiplied by 3. So root 9 can be written as only 3, and 3 is the integer. So square root of 9 is not a surd. Next example is saying that cube root of 9 is a surd. While square root of 9 was not a surd, but here cube root of 9 is a surd. Why it is surd? Just the reason is shared here. When you will take the cube root of 9, we are unable to get the three identical factors of 9. And by using the calculator, we will see that it will give us 2.08008 and dot. It means the division is ongoing, the value is ongoing, and there is no specific repetition of the digit after the decimal point. So, cube root of 9 is a surd. Square root of 81. It is mentioned it is not a surd. Why it is not a surd? Good. The same meaning as we already shared, square root of 9 is not a surd because square root of 81 means we are able to make the two identical factors of 81, which are 9 multiplied by 9. So square root of 81, we can extract out 81 as in the form of 9. So it is not a surd. In last example, we are having square root of 24, and it is mentioned here that it is a surd. Why it is a surd? The same reason, because we are unable to get the two identical factors of 24 from the radical signs. It cannot be extracted out, so under root 24 is a surd. So what does it mean? Only those radical expressions which cannot be extracted out from their radical sign by cancelling their index, so they all are called the surds. Whereas that expression, that radicand which can be extracted out from the radical sign by cancelling out the index, so they are not a surd. For example, root 144. Just check it. Root 144. 144 is a perfect square number, so it can be extracted out in the form of 12. So it is not a surd. Whereas root 130, what about this? Good. Root 130 is a surd because we are unable to get the two identical factors of 130. So all those which cannot be extracted out from the radical sign, they are called the surd. For example, under root 45 means square root of 45. And when we make the factor of 45, it will be break into 9 multiplied by 5 inside the radical sign. Or we can say that it can be written as under root 9 multiplied by under root 5. So as we know, under root 9, the square root of 9 is a perfect square number. So it can be extracted out from the radical sign in the form of 3. Whereas 5, which is also inside the radical sign, but 5 is not a perfect square number. We are unable to get the identical pair of factors, so it will remain same. So root 45 is equals to 3 root 5, means it's a good, it's a surd, because 3 is although is present in the form of coefficient, but root is present by having the 5 as the radicand. So it's a surd. Next example is saying cube on the A and it is inside the radical sign, means square root of a to the power 3. When we will make its factor, it will break into a square multiplied by a, having the same meaning. The product will be a to the power 3. From that a square, which is inside the radical sign, we can take out 1 of the a by extracting from the radical sign by cancelling the 1 over 2, multiplied by the single a will remain inside the radical sign. So finally we will have a under root a. Again here we have under root a which cannot be extracted out from the radical sign. So this expression is also a surd. Rationalizing the denominator. Before discussing the rationalization the denominator, it is necessary that why we want to rationalize some expressions. Reason is that whenever we have a surd in the denominator, for example, we have 1 over root 5. So root 5 is a surd, and we know surds are the irrational numbers. So if there is 1 over root 5, the overall expression become irrational number. For that reason, whenever we have the situation of irrational number, the mathematics support us to rationalize that number, means to convert that irrational numbers into rational numbers. So we have number of processes how to rationalize the denominator. The process by which a fraction is rewritten so that the denominator contains only rational number. Just link this statement with my previous statement which I used, why we rationalize the denominator. A variety of techniques for rationalizing the denominator are demonstrated below. We will discuss that different variety or methods that how to rationalize the denominator in the presence of surds. So let's see the different examples. The square root, right? If you observe the example number 1, it is saying that a over root b. What do you think? Is it surd root b? Okay, because b is not having the square on that, so it means it cannot be extracted out from the radical sign. So overall expression a over root b is irrational and surd. And how will we remove? As we have discussed, the rationalization method means we have to change the irrational numbers, irrational expression to rational expressions. So this is monomial surd. Why this is monomial surd? Because in denominator we have only one term and which is the surd. So how to rationalize these monomial surds? That is, we multiply and divide by the same denominator. The given expression, the given surd will multiply and divide by the same denominator. So in this case, because we have a over root b, so the expression will be multiply by root b as well as divide by root b. Then what happened? As we know, numerator multiply by numerator, it become a root b, and in denominator you can see that root b multiply by root b, and in the below slides you can see that root b multiplied by root b is equals to root b square, and then 1 over 2 will be cancelled by the square of the 2, so b will be extracted out. Means we have removed the radical sign from the denominator. Now whatever the expression we are having, this is without radical sign in the denominator. In the same way, we can discuss the example here. It is 4 over root 2. Means a is 4 and b is root 2. By using the same method, we can rationalize this denominator that 4 over root 2 will multiply by root 2 as well as divide by root 2. In numerator, 4 multiplied by root 2, and in denominator, root 2 multiplied by root 2, it will make the pair and extract out from the radical sign in the form of only 2. Then 4 root 2 upon 2, we will reduce the fraction. 4 is divided by 2, so 2 ones are 2 and 2 fours are 2 twos are 4. So finally we have 2 root 2 is the simplest form of the given 4 over root 2. From the denominator, radical sign has been removed. Now it is in numerator. In numerator, radical sign is acceptable for mathematical calculation, but denominator situation become irrational. That's why we accept in numerator, whereas denominator we have to remove that. The previously we have discussed that how to rationalize the monomial expression. Now come to the binomial surds in denominator. So a over b plus root c. Two terms are involved here in denominator, b plus root c. So it is binomial surd. Why it is surd? Because root c is there, which is not having the formation of the extracting out from the radical sign. So to rationalize these binomial surds, we use one type of expression which is called conjugate. What is conjugate? Conjugates are the same binomial surds but having different mid sign. In between sign will be inverse. For example, if we have a plus root b, so conjugate will be a minus root b. If we have 2 plus root 3, so conjugate will be 2 minus root 3. If we have 1 plus root 2, so conjugate will be 1 minus root 2. Similarly, the sign will be changed vice versa. So here we have a over b plus root c. So in the same way as we use in previous, multiply and divide by the denominator the expression. That is b minus root c. We write here the statement multiply and divide by the conjugate. And then numerator multiply by numerator and denominator multiply by denominator. So in numerator we will have a will multiply with b, so we get ab, and the same a will multiply with the minus root c, so it become a minus sign is there, plus minus minus a root c. Whereas in denominator we will have the formula situation, that is b square minus c square. How it is? Let's see below the slide that as a plus b multiplied by a minus b is equals to a square minus b square, right? So in the example, we are using the same thing, b plus root c multiplied by b minus root c. It will give you b square minus c square. C square is not visionable here, but you may consider that because we have the reference of the formula, so it would be c square, right? And now by using the same method, we have the concrete example of the integers, that is 6 upon 3 plus root 7. 6 is the numerator and denominator we have the binomial surd 3 plus root 7. Root 7 is the surd, So when the expression is containing at least only one radical sign and it is consist on two terms, so that is called binomial surd. So for using the rationalization method, we will use the conjugate, that is the whole expression will multiply and divide by 3 minus root 7 in numerator as well as in denominator. Then in the same way, numerator multiply by numerator, denominator multiply by denominator. You can see 6 will multiply by 3. Okay, 6 3 is 18. Plus minus, minus, and 6 multiplied by root 7 will be as it is 6 root 7. And what is happening in denominator? You can see 3 plus root 7, 3 minus root 7. They both are going to multiply. So a plus b, a minus b is equals to a square minus b square. So what we get? Good, 9 minus 7 in denominator. And then after simplification, we will have 9 minus 3 root 7. Another method is also shared here by showing or, that is 18 minus 6 root 7 upon 2 can be simplified by taking 6 as the common factor from the numerator, and that 6 will be reduced by the denominator, which is 2, 2 1 is 2, 2 3 is 6. So we have 3 minus root 7 and 3 will be coefficient after the reduction. So it is 9 minus 3 root 7. By using any of the method, we will get the same answer, 9 minus 3 root 7. Now, if the denominator is having the two term binomial surd and both expressions are the surd, root b and root c. So, a over root b minus root c, how will we rationalize this? We have to rationalize because the presence of surd in denominator makes the expression irrational. So how to make it rational? We multiply and divide by the conjugate. And you can see conjugate. Root b, okay, root b is there. Root c, this is also there. But in denominator we have negative sign and in conjugate we have positive sign. The opposite sign of the two term in between sign, so they are the conjugate. We multiply and divide by the conjugate. Then same thing, numerator multiply by numerator, so it becomes a root b plus a root c, and in denominator root b multiply by root b, that would be root b square on that, root c multiply by root c square on root c, negative sign is there, formula is saying a plus b multiply by a minus b is equals to a square minus b square. Good. So finally we have b minus c. Radical has been removed from the denominator. Now come to the mathematical values. It is 12 upon root 15 minus root 7. Right. Binomial surd is present in denominator. How will we rationalize it? By using the conjugate, that is root 15 plus root 7. It will multiply the expression as well as it will divide the expression. So when the 12 will multiply with the root 15, it becomes 12 root 15 plus 12 root 7. In numerator, we have the binomial expression having the surds. But in denominator, we have removed the radical sign by applying the formula a square minus b square is equals to a plus b and a minus b. So it becomes 15 minus 7. Finally, we have 12 root 15 plus 12 root 7 upon 8. So this is the simplified form by using the method of rationalization of the given expression. Now come to the exercise. Exercise 2.8, question number 1. Instruction is that rationalize the denominator of the following. As we have discussed that whenever the surd is present in denominator, so it makes the expression irrational. We have to make the expression rational by rationalization. So 1 over 2 plus root 3, we will use the conjugate. We have already discussed the method of conjugate previously. That is 2 minus root 3 multiply upon 2 minus root 3 means by using the conjugate, we are multiplying and divide the given expression. Then numerator multiply by numerator, there is 1, so there will be no change in 2 minus root 3. And in denominator, we will apply the a plus b multiply by a minus b formula. So what happened? Square on 2 and square on root 3. So 2 become 4 and root 3, square on root 3, it will be extracted out from the radical sign, it is only 3. So 2 minus root 3 upon 1. In denominator there is 1, so there will be no change in numerator, so we can write as 2 minus root 3. You have seen that from the denominator we have removed the radical sign, we have removed the surd, so the expression is rationalized. Now question number 2 of the same exercise, and listen carefully, follow the steps and focus on the language whatever I am using here. Question is that if x is equals to 2 minus root 3, find the values of x plus 1 over x and x square plus 1 over x square. You may tally the question from your exercise. Good, question is correct. Now start the solution. According to question, we have x is given and we have to find the x plus 1 over x. So what do you think? From where we will get 1 over x? Obviously, we have to calculate out from the given information. So as we have x is 2 minus root 3, then 1 over x. Good, inverse of that. X and 1 over x are the reciprocal. So similarly, if we are taking the reciprocal of x, we have to take the reciprocal of value also. So 1 over x will be equals to 1 over 2 minus root 3. Now situation is irrational. Surd is present in the denominator. What we do? Good. We will rationalize the denominator by the help of conjugate. So 2 minus root 3, its conjugate will be 2 plus root 3. We multiply and divide by the same conjugate. Then numerator multiply by numerator, so it becomes 2 plus root 3. And in denominator, we will apply the formula a minus b multiplied by a plus b is equals to a square minus b square. So 2 plus root 3 in numerator, and in denominator when we take square on 2 it becomes 4, and we will take square on root 3, it will be extracted out from the radical sign, it is only 3. So what is the value of 1 over x? 1 over x is equals to 2 plus root 3. This is only, directly they are not asking to find the 1 over x, but to find the value of x plus 1 over x, we need to find 1 over x, and which we have already calculated. Now come to the actual question. They are saying find x plus 1 over x. At this stage, x is given in the question. The value is given 2 minus root 3. And 1 over x, we have already calculated 2 plus root 3. So x plus 1 over x is equals to the value of x plus the value of 1 over x. So 2 minus root 3 plus 2 plus root 3. So this is the value of your 1 over x, 2 plus root 3, right? Make it clear. When we solve this expression, what we observe? Minus root 3 and plus root 3. What happened? They will cancel each other. Because the same value having opposite sign, they are the additive inverse of each other. They will cancel each other. And finally, we have plus 2 and plus 2. We will add them. So x plus 1 over x is equals to 4. This is first finding of the question. Now, secondly, they asked to find x square plus 1 over x square. How will we find this? Good. Because we have the value of x plus 1 over x, so why not we are taking square on that? So by taking square on x plus 1 over x, we may get the value of x square plus 1 over x square. As we are taking square on left hand side, ultimately we are working on equation, we have to take square on right hand side also. So by taking the square on the equation, what happened? The left hand side will be expanded by means of formula. What formula is saying? That is a plus b whole square is equals to a square plus 2ab plus b square. Similarly, if the a and b are in the language of x and 1 over x, so a square means x square plus 2 from formula, x is your a, 1 over x is your b, plus square on 1 over x. So just see the middle term. 2 multiplied by x multiplied by 1 over x. What happened? X will cancel out and we have only 2. So x plus 1 over x square will be equals to x square plus 2 plus 1 over x square. This is the solution of your left hand side. Now right hand side we have square on 4. Good. We know 16. And then because we have to find the value of x square plus 1 over x square, what we do? Right. We will shift this plus 2 on either side. So it becomes minus 2. So 16 minus 2 is 14. So finally x square plus 1 over x square is equals to 14. Be careful while solving this type of question. There will be any error in the sign. Will change your values. So be conscious while using the sign and cancellation. Question number 5. And it is if y is equals to root 5 minus 2, find the values of y plus 1 over y, y minus 1 over y, and y square minus 1 over y square. So 1 over y we have to find because y is only given. We will find the 1 over y by using the rationalization method. You can see here method is given, steps are very much clear, language is very much clear. So 1 over y will be equals to root 5 plus 2. And if we have the value of 1 over y, so it is not difficult to find the y plus 1 over y. So it is y, the value of y, which is root 5 minus 2 plus the value of 1 over y root 5 plus 2. You can see minus 2 plus 2 are present in the expression. They will cancel out each other. We have root 5 plus root 5. How many root 5 we have? Good, 2 root 5. So the value of y plus 1 over y is equals to 2 root 5. How to find y minus 1 over y? Simply by subtracting the both value, but make sure that you are using the parenthesis to maintain the sign. So root 5 minus 2 minus root 5 and minus plus minus 2. Now what happened? Plus root 5 minus root 5 will be cancelled and we have minus 2 and minus 2. Same sign, like values, so it will be added. So y minus 1 over y is equals to minus 4. And how to find the y square minus y square? It is similar as a square minus b square, and we know that is equals to a plus b and a minus b. Already we have calculated the y plus 1 over y and y minus 1 over y. Just do the multiplication and we get the answer. That is minus 8 root 5. That is 2 multiplied by minus 4 and root 5 is there. So minus 8 root 5 is the value of y square minus 1 over y square. Question number 8. If 1 over b is 2 plus root 3, find the values of b to the power 4 plus 1 over b to the power 4. So first we find 1 over b is given. So first we find b. And b and 1 over b are the reciprocal of each other. So this time for finding the b, we will take inverse of the value of 1 over b, that is 1 over 2 plus root 3. And by using the method of rationalization with the help of conjugate, we will find the value of b, that is 2 minus root 3. Then b plus 1 over b. When we have in the question 1 over b is given, we have calculated the b, just add them, you will find 2 minus root 3 plus 2 plus root 3 minus root 3 plus root 3 will be cancelled and we get the 4 as b plus 1 over b. And how to take the square of that b square plus b square? Because why we are taking a square on this? We don't have any direct formula to find the b to the power 4 plus 1 over b to the power 4. So it is similar to the previous question that we use the x plus 1 over x and the whole power 2. Apply the formula on left hand side as well as on right hand side. So you will get the b square plus 1 over b square is equals to 14. And for the b to the power 4 plus 1 over b to the power 4, taking square again on that, the same method, apply the formula and simplify the expression, you will get b to the power 4 plus 1 over b to the power 4 is equals to 194. Now the home task, question number 1, part 1 and 3, instruction is given. You may take help from that. Question number 3 and 4, question number 6, 7, question number 9, 10, question number 11, simplify the order. Order means the index. Whatever the index, that is the order of that third. So this is all about from my side. Time is going up. Thank you. Allah Hafiz.